All right, in 6.5, we're going to be looking at what we call the laws of logarithms. Since logarithms are exponents, that also gives to the rise for the laws of logarithms. So we're going to define these laws, and that's what we do in math all the time, to where we say we're going to let a be a positive number, that's our base, not equal to 1. And then we're going to let our capital letters represent any real number, again, being greater than 0. So, when we talk about A, B, and C being real numbers, it's not always going to be like 1, 2, 3, 4, 5. A can also stand for x, x plus 2, x minus 1. It can stand for anything because we always assume that x and y, are numbers. So in this case, we're assuming that x and y are real numbers. So let's just look at the three laws we're going to be looking at. The first law is if you have a single logarithm with two items multiplied together, so the log of a product, we can rewrite it as the log of the first expression plus log of the second expression. So the description is the logarithm of a product of numbers is the sum of the logarithms of the numbers. The example I have here is, let's just say I had the single log of x and y. It's the log of x plus the log of y. Second law is the log of a quotient. So if you have the log of a divided by b, we can write it as the log of the numerator minus the log of the denominator. So again, the logarithm of a quotient of numbers is the difference of the logarithm of the numbers. So another example is if I have the log of x over x minus 3, well, it's the log of the numerator minus the log of the denominator. One thing you have to remember, you don't distribute logs, just like we don't distribute exponents. The only thing we can distribute is multiplication and division. So the log of x minus 3, there's no law for that. It's just that's as far as you can go. The third law is if I have a log of an expression raised to a power, I can rewrite it as the power times the log. Example of this is if I have log of x plus 3 raised to the third power, I can rewrite this as 3 times the log of x plus 3. So the description, again, the logarithm of the power of a number is the exponent times the log of the number. So always remember to read your directions. When you are writing logarithms as a sum or a difference or whatever you're asked to do, you're not solving, you are just rewriting. So looking at this expression here, this one looks like law 1. So I just say it's equal to what law 1 tells us it's equal to. So this would be the log base 2 of 6 plus the log base 2 of x. And that's it. That's all you can do with it. Now, possibly if we were solving equations or something, we could make this into an actual number. But for right now, that's all we're doing. Now, the next one here, let me get a little better focus. We've got log base 5 of another product. So I say this is log base 5 of x cubed plus log base 5 of y to the 6th. Now, you don't need to put parentheses around it. I'm just doing it. You can really just write it as this, and you're fine. So once I separate using one law, I look at single logs because, see, all of these laws right now on the left side all relate to single logarithms, and they tell us what we can do. So I look at each single log, and each one I have looks like law 3 here. So that tells me I just say this is 3 log base 5 of x plus 6 log base 5 of y. And you're done. And you're done. The third one involves still a product, but we have a square root. So we're going to have to do something with that. And I'm going to kind of take this one on the back of the page, just because I'm not going to have room. So if I have log base A of x times the square root of x squared plus 1, I'm going to use law 1 to take the log of the product into the sum of individual logarithms. And I'm just going to keep working with this. Now I look at this first one, that's simplified. Nothing else I can do with that. But the second one, we have a square root. And the square root is a 1/2 power. So we can make the square root into the exponent. And then I can apply law 3 to simplify that. Now you cannot do anything with this exponent inside because it's inside the parentheses. We do not have a law to separate a sum, so that's all you can do with that. So this is simplified. It's expanded. We have written them all into single logarithms. Okay, going back now, we're going to look at working with law 2. Get a better angle with this camera. Okay. So now I'm going to write these single logarithms as a difference. So this looks just like law 2. That's all you got to do for these. And if I have the log, and it doesn't matter, natural log, common log of a quotient, we take the log of the numerator minus the log of the denominator. So this right here would give us natural log x squared minus natural log x minus 1 cubed. Looking at each individual logarithm, I can now go to law 3 and deal with my exponents. So that's 2 times the log of x minus 3 times the log of x minus 1. Done. Part B, a little more difficult because see what we have here in the numerator, we have a product and we also have a square root. So this one's going to be a little more involved, but always apply law 2 first when given the choice. Okay, so when given the choice, we're going to apply law 2. So this is going to be the log of the numerator minus the log of the denominator. I'm going to apply law 1 here. So this is the log of x cubed plus the log of the square root of x squared plus 1 minus the log of x plus 1 to the 4th. So I look and I've got every logarithm is a single logarithm. There's no more products, no more quotients. Now I'm going to look to apply law 3. In this case here, I'm going to go ahead and take care of this square root and make it a 1/2 power. And now I'm going to apply law 3, which gives me 3 log x plus 1/2 log x squared plus 1 minus 4 log x plus 1. And that's as far as I can go with that. Get that up there for you. So you can see I've got single logs. There are no products, no quotients, cannot do anything with the sum, cannot do anything with the power inside the parentheses. So that's what we do when we separate single logs into multiple logs. Now we're going to look at working backwards. We're going to be taking sums of logs, differences of logs, and rewriting them into a single logarithm, which is what we're going to need to be able to do in 6.6 for solving some equations. So make sure you really understand how to combine these. So if I take 3 log x plus 1/2 log x plus 1, well, I'm just working backwards. So the way we work backwards is whatever we did last when we separated logs, we do first when we're combining log. So we do log 3. So we take care of our exponents. And the 1/2 power makes the square root. So now if I look at this, it looks like this. So I'm working back to get to this. So I take the log of a sum, 2 logs of a sum, and make it into single log. So this is the single log of x cubed times the square root of x plus 1. In example 4, we have a difference of 2 logs. So the difference means we apply law 2, but first we have to apply law 3. So this is the natural log of x minus 1, natural log of x plus 4 cubed. Again, looking back at our laws, we're right there. We want to end up with this. So I say, okay, that is the single log, and then I create my quotient, x minus 1 over x plus 4 cubed, and I'm done. Okay, so we've separated single logs into multiple logs into single logs. Last thing we want to look at now is how do I evaluate logarithms in my calculator that do not have base e or base 10. So in this case, we have what's called the change of base formula, where b is our base, x is our number, and if I want to know what it is, I put it in my calculator as log x over log b. So for log base 8 of 5, that would be log 5 divided by log 8. So make sure you're working these with me. Don't just copy it down. You need to know how to use your calculator. So I just put in my calculator log 5 divided by log 8, and I get 0.77. And the way you can check these is, we've created this equation now. Log base 8 of 5 is 0.77. So changing it to an exponential equation, 8 to the 0.77 power should be 5. That's how you can check it. Log base 9 of 20 is log 20 divided by log 9. So it should be, we're thinking about a power of 9 to give us 20, should be somewhere between 1 and 2. And I get 1.36. Log base 5 of 125 is log 125 divided by log 5, and you should get 3. The last one, log base 8 of 150, is log 150 divided by log 8. And I get 2.41. So the common mistakes that I see students doing these is they do them backwards. You know, you got to remember what goes in the numerator, what goes in the denominator, how to put it in your calculator, and then making sure that if you have a calculator where you can see everything as you type it in, you've got to close this parentheses here. So it's pretty apparent how I've written them. You have to make sure you enter them the way I've written them. So that'll be it for 6.5. We will do more examples in class.